So that's a cosine. You know that one? Okay, we got number 1.
What? No. Bill, you're welcome, by the way. Thanks, Tim, I love you.
Hey, we did.
I really love you.
You were here for the evens, right? And then Thursday, we went over the evens, and y'all did the odds
I was
on
not.
1 through 8. Yeah. So let's go over. I'm going to go over one of each: a cosine, a sine, and a tangent. And what?
We do review Friday.
I meant Tuesday. Tuesday we did the evens, and then Wednesday or Thursday we did the odds.
Okay.
And then Friday we didn't do anything.
Friday we
so
can come in
now,
here.
What are we looking together now? Because we were all.
All right, let's look at this one.
What am I supposed to be at?
Number 1.
Oh.
We've got the cosine of theta equals 3/5. All right, it's on the interval of 270 to 360. What quadrant is that in?
Is this the new lesson?
Nope.
Sorry.
It's the same one.
Of what?
We talked about, so far, only thing we've done is double angle identities.
I wasn't here for that lesson.
So, beginning of it.
What are we talking about? When
We
did
just
this
do
lesson, when did this lesson start?
Monday.
After the test.
All right, so if you look, I gave you all these papers as well. The second week we were here. Christmas.
Did we find out wait on that?
Has it taken it?
Nope.
I think maybe that's enough. I need to.
You need to take it.
Tomorrow,
I'm trying to
you're taking it
All right,
tomorrow.
I'm trying to get a 70 right now, and you haven't even taken the test.
All right, so if you look,
I have to make a-
what quadrant, listen. What quadrant is 270 to 360? Fourth. If you look, what do you know about the fourth quadrant, sine, cosine, and tangent wise?
Sine is negative, positive.
You look, sine is negative, cosine is positive, tangent is negative. Okay, so this cosine is still positive, which is right. This is x, this is r. What do we have to find? Y. If you look on the left side where it says r equals the square root of x squared plus y squared, we can manipulate that. We can take that equation and we can say y equals the square root of r squared minus x squared. We can manipulate it. Alright? Plug these two values in. We get y equals the square root of 25 minus 9. Alright? So y equals the square root, what's 25 minus 9?
16.
16. And that is 4. What type of 4 does it have to be if it's in the fourth quadrant? What does sine have to be? Sine has to be negative. So if sine has to be negative, this y has to be negative. Okay? Because we know r is positive. Alright, so if we know cosine, now we can say, well, the sine of theta equals negative 4/5. Alright, if we know sine and we know cosine, we have enough to find our double angles, all 3 double angles. Correct? Okay, so if you look, how do you find the sine of 2 theta? Look on your paper right there. 2 sine theta cosine theta. So the sine of 2 theta equals 2 times the sine of theta, which is negative 4/5, times the cosine of theta, which is 3/5. All right, how do you multiply fractions? Straight across. Is that 2 a numerator or denominator? That is a numerator. So we've got 2 times 4 is 8. 8 times 3 is 24. So this equals 24, that's a negative, over 25. And that's the sine of 2 theta. Okay? Now, if you look at your double angle identities, the cosine of 2 theta, there's 3 different equations we can plug it into. Alright? For me, in my opinion, the easiest one is going to be 2 times the cosine of theta squared minus 1. In my opinion, that's the easiest one. Alright, but the first thing we have to do is we got to square this fraction. How do we square a fraction? Square the numerator, square the denominator. Right? So we've got 2 times 9/25 minus 1. Well, 2 times 9 is 18, so we've got 18/25 minus. What does this 1 have to become so I can combine it with this fraction? 25/25. That's what it has to become. What's 18 minus 25? What type of 7? Negative. So this becomes negative 7 25ths. So now we have the sine of 2 theta and the cosine of 2 theta. What's left? The tangent of 2 theta. Well, if our angles are all the same, in this case they are, that's 2 theta, that's 2 theta, and we want the tangent of 2 theta, how do we find the tangent of 2 theta? Sine over cosine. So the tangent of 2 theta equals the sine, which is negative 24 25ths, over the cosine, which is negative 7 25ths. Key flip change. So this is negative 25 sevenths. That's gone. The 25's cancel. You've got a negative times a negative, so that becomes positive 24 sevenths. And there's our 3 answers, here, here, and here. All right, so what's the first step? Find y, x, or r. Okay. What's the second step? And then find which sine or cosine, right? What's the third step? Just your double angles, right? Just your double angle identities. That's the 3 steps. What I mean by here is find sine of theta, cosine of theta, just as a single angle identity. Alright, and then double angle identities. And that's the 3 steps. 3 steps to this. Alright? Okay, let's look at a different one. Let's look at a sine problem. Let's look at 7. Okay, we've got the sine of theta equals 4/5. On the interval pi over 2 to pi. So what quadrant is pi over 2 to pi? Second. Because we go from 0 to pi over 2 to pi to 3 pi over 2, and then back to 2 pi. Alright, so this is the second quadrant. What do you know about the second quadrant? What has to happen? Sine's positive, cosine's negative, tangent's negative. Okay? Do what? Alright, since this is sine, we know y and we know r. So the first step tells me what do I have to find? In this case, x. Alright? So, manipulate the r formula. X equals the square root of r squared minus y squared. So x equals the square root, r is 25, y is 4, so that's 25 minus 16. What's 25 minus 16? 9. And what's the square root of 9? 3. So x equals what type of 3? What does cosine have to be? Positive or negative?
Negative.
Negative. So x has to be what type of 3? Negative 3. Now I can find the cosine. Well, if my sine's, that's y and that's r, and the cosine of theta equals negative 3 over 5. Okay? That's the second step. We found sine and cosine. In this case, we found cosine. So now we have sine and cosine. Third step is to find your double angles using your double angle identities. Alright? So the sine of 2 theta equals 2 times the sine, which is 4/5, times the cosine, which is negative 3/5. Well, 2 times 4 is 8. 8 times 3 is negative 24/5. Wow. Strangely similar. Alright? Sorry, 25th. Okay. The cosine of 2 theta. Well, I'm still going to say 2 times the cosine squared, so negative 3/5 squared minus 1. Same thing, square what's in here. 2 times 9 25ths minus 1, well, 2 times 9 is 18. 25ths minus 25 25ths. So that equals negative 7 25ths. And these are exactly the same answers. Awesome. All right, so the tangent of 2 theta equals the sine of 2 theta, negative 24 25ths divided by the cosine of 2 theta, negative 7 25ths. Keep flip change. 25's cancel, you got a negative times a negative, so that's 24 sevenths, and they're exactly the same. The only difference is what?
Sweet. The negatives and positives.
Your sines and what quadrants in based off your single angles. That's the only difference. All right, let's look at the tangent one. Which tangent ones did we go over the other day? We could do 5. We didn't go over 5.
Yeah, we just go across.
All right, number 5 says tangent of theta equals negative 1/2. All right, so we're on the interval from 3 pi over 2 to 2 pi. What quadrant is that? Fourth quadrant. 3 pi over 2 to 2 pi. Okay, in the fourth quadrant, what do we know about sine, cosine, and tangent? Look, sine is negative, cosine is positive, tangent is negative. Okay, we know tangent is negative because it's already negative. All right, so if cosine is positive and sine is negative, which one of these has to be positive and which one has to be negative? This is y, and this is x.
So y has to be negative and x has to be positive.
Why?
Because y comes from sine and x comes from cosine.
Correct. Okay, so now we just have to find r. Step 1, find r. So r equals the square root of x squared. So we've got 4 plus y squared, which is 1. So r is the square root of 5. Correct? That's it. If that's not a perfect square, leave it square root of 5. All right? R is going to be positive. Okay, so now we can find the sine. So the sine, in this case, we've got to find both, sine and cosine. Right? Because we have to tangent, so we've got to find sine and cosine. Well, it's okay, we've got everything we need. All right, for the sine, it's negative 1 over square root of 5. But what happens now? We have a radical in the denominator, so this has to become, we've got to rationalize this. All right? So we have the negative square root of 5 over 5. The cosine of theta is 2 over the square root of 5. Still have to rationalize it because of the radical in the denominator. So we got 2 square root of 5 over 5. All right? Now, what do we do from here? Okay. So now we've got sine of 2 theta. Okay, what does that equal? Well, if we say 2 times our sine, which is negative square root of 5 over 5, times our cosine, which is 2 square root of 5 over 5. Well, 2 times the square root of 5 gives me what? Negative 2 square root of 5. And then multiply that by 2 square root of 5, we get 4 times 5, which is 20, but it's negative. Negative 20 25ths, we can reduce that. Both of them by 5, so we got negative 5, 4, or negative 4/5. All right, so that's the sine of 2 theta. All right, with this one, the easiest one to square, is going to be sine, because there's only one term in the numerator, correct? So if I'm looking to see which one of these double angles I'm going to use for cosine, I'm going to use 1 minus 2 sine squared theta. So the cosine of 2 theta equals 1 minus 2 times the sine, which is negative square root of 5 over 5. And that's squared. So still, square, what's in the parentheses? So we've got 1 minus 2 times 5 over 25. Well, we could reduce this, but we'll wait. So we've got 1 minus 10 25ths. So this becomes 25 25ths minus 10 25ths. What's 25 minus 10? 15. So we've got 15 25ths. And this reduces to 3/5. Alright. Now the only thing left to find is the tangent. So we've got the tangent of 2 theta equals the sine, which is the negative 4/5, divided by the cosine, which is 3/5. Keep flip change. 5's cancel. So the tangent is negative 4/3. Okay? We understand these? 3 steps. Now, there's some work in those 3 steps, but it's only 3 steps. Big time. All right. Next thing we have to talk about would be solving an equation using a double angle identity. All right, so let's look at this. If we've got, and this is something new, so you probably need to take notes on this. All right, let's set it first.
Don't do it.
I can't send something to
Don't do it.
You have to throw it. Please lay over that, please.
Okay, let's look at this. We're solving for theta. All right. Right now, the problem is we have a sine of 2 theta and a sine of just theta. Right. To combine these, the angles have to be the same. Well, right now we've got a double angle and we've got a single angle. So the goal is to get this double angle to a single angle. Okay, that's the goal. All right. This is also important. This is the interval that it's on. Why is this important? Why is the way it's written, the notation it's written in, important?
Because the sign has to be.
Well, not exactly. It's close. But what does the bracket mean? When I'm solving for theta, I'm going to solve for theta in terms of radians. Okay? Now, sometimes those radians include 0, and even though 0 and 2 pi are the same line, they have 2 separate initial and terminal sides. For 0, the initial side and terminal side are the same. Okay? For 2 pi, we have an initial side, and then we go all the way around and then back to 2 pi. So the terminal side, even though it looks the same, it's not. It's telling you what's happening with the angle. Okay? So, what is these brackets? Why is this important? What if we've been written like this? Exactly. If we've been written like that, which one's included? 2 pi is included. Okay? But it's not written that way. It's written like this. 0 and 2 pi. Alright, so both are included. Alright, so I'm going to take this double angle and I'm going to put that in terms of the only way I know how to put it in our single angle identity. So we've got 2 sine theta cosine theta minus the sine of theta equals 0. Right? How many terms are on the left side? 2. What do they both have?
Sine.
A sine. So let's factor a sine theta out. We're left with 2 cosine theta minus 1, and both of those equal 0. Okay, now listen to the question. It's not how many terms are on the left side, it's how many factors are on the left side. Now, 2. There's 2 factors, right? We know a property, it's called the zero product property. That tells me I can set each factor equal to 0 separately. All right? So what I mean by that is I can take the sine of theta, set it equal to 0, and I can take 2 cosine theta minus 1 and set it equal to 0. Does that make sense? Now I just solve for theta on both of them. This one's already done. Look on your unit circle. When does a sine of theta equal 0? Happens 3 times. Yep. Sine. Pi and 2 pi. 0, pi, and 2 pi, right? So if you look, quadrantal angles, you go 0, so that, because it's included, then you go to pi, which is 180, and then back around to 2 pi. Okay? Now we have to solve. This is a 2-step equation. Add 1, so we've got 2 cosine theta equals 1. Divide by 2, cosine of theta equals 1/2. Well, when does the cosine of theta equal 1/2? Look on your unit circle. It's got to be positive 1/2. Should happen twice. Pi over 3 and 5 pi over